So this video is going to be the homework review for this week. Again, I'm just going to take some of the basic problem types of the homework and show you how to do them. Some of these might be more sort of the basic versions of, well, basically AKA not word problems for some of them. So on your RPS, you might have a few word problems that don't show up here, but that's, again, sort of testing you to see if you can't take the basic knowledge and apply it to a word problem. And again, the word problems don't require that much extra effort, so don't freak out about them. So let's get started here. We have a shed here in the shape of a rectangular prism, and it says that the shed does have a floor, and it says how much storage space does the shed hold. And so this type of problem is kind of seeing whether you can deduce whether you're going to use volume or surface area. So remember, surface area is how much stuff would cover the object. Like if you were to paint or to coat something, how much would you need? That's a surface area. Whereas volume is how much space is inside the object or how much space the object can hold, which in this case here, how much space does the shed hold? That means we're going to be using a volume question. So this is a volume formula question, which, if you don't remember, is area of the base times the height for a prism. And since it's a rectangular prism, we know that the area of the base is just length times width, and then we're just going to times it by the height. Because again, this capital B here is just length times width. That's the area of the base. Well, the base is a rectangle, so it's just length times width. So it'd be 13 times 8 times 12, which I would go down here and do 13 times 8 times 12, and we get 1248. So 1248 feet cubed. So that would be how much space the shed holds. And again, it's a volume question because you're talking about holding a space or taking up a space. In this case here, it says the shed is to be lined with a thin steel covering even the floor. How much steel is needed? So we're going to basically cover all the exterior or interior, actually doesn't say, but we'll say one or the other. We're going to cover all the sides of the object with a thin steel covering. Well, that's a surface area question because you're talking about covering a space or covering an area. So we're going to do the surface area formula, which doesn't really have a formula. For the surface area for rectangular prism, if you remember what we did was we kind of paired each number up once. So we have a 13 by 8 by 12 prism. And for a rectangular prism, what we did is we could cut it up into like 6 different rectangles, or we could just, again, do our pairing trick. So we pair the 13 and the 8, we pair the 8 and the 12, and we pair the 12 and the 13. And then because we're going to be covering each side here, even the floor and the ceiling, we're going to times each of these by 2 because this right here is the top, so we times it by 2 to get the top and bottom. This right here, 8 by 12, which is this side right here, that's the left, so we need to multiply it by 2 to get the left and right. And then 13 by 12 is the front, so we're going to multiply that by 2 to get the front and the back. And then we're going to add up all our answers afterwards. So we have 13 times 8 times 2, which gives us 208. Here we have 8 times 12 times 2, which we give 192. And we have 13 times 12 times 2, which gives us 312. And then we add these together. 208 plus 192 plus 31.2, and we get 712. So this would be how much surface area covers the object. 712 square feet. That's how much steel we would need. And again, if they say like steel costs $2 per square foot, how much would it cost? You just end up multiplying this by however the cost is, and you get how much to pay. Excuse me, hiccup. So again, this question was just kind of testing to see whether you know the difference between a volume problem and a surface area problem. Sorry, I got a little hiccups there. So let's talk about this one here. So this is a composite volume. We have this figure here that's not a prism per se, but it's a composite figure. It's made up of different pieces, and we want to find the volume. So the first thing you do when you have a composite figure is you have to cut it into pieces you know how to work with. So for me, I would probably cut it like this. And I have this rectangular piece over here, and I have this other rectangular piece over here. So I'm going to find the volume of these two prisms and then add them together. So I'll start with the green one first. So the green one has a height of 4. It looks like it has a length of 7 and a width of 3. So it's a 4 by 7 by 3. So we do 4 by 7 by 3. And again, it's a rectangular prism, so we can just multiply all these together. So 4 times 7 times 3. We get 84 feet cubed if you want to label it. I'll label mine at the end. For the blue one, let's see here. For the blue one, it looks to be now, excuse me. We have to be a little careful here because this 11 feet means the entire thing is 11 feet. I don't want the entire thing, I just want this blue line right there. Well, I know that this green line here is 3 feet, which means this green line here is 3 feet, which means this line right here also has to be 3 feet because again, they're going in kind of the same direction there and the same distance. So if that's 3 feet, that means that this blue line right here has to be 11 minus 3, which would end up giving you 8. So that blue line there is 8 feet. So this is 8 feet long, or wide, depending on how you call it. 8 feet by this distance right here is 7 feet, so times 7. And then the height here is 2 feet, so times 2. And you can also see that there's an 8 feet right there. It's actually labeled right there, which we'll just pretend that I actually saw. And I just wanted to do this just to show you that if they didn't give you that 8 feet, you'd have to subtract it like that. So we'll go with that explanation. So we do 8 times 7, which is 56. So 8 times 7 times 2, we get 112. And then we just add. So 112 plus 84. And we get 196 feet cubed. And that would be the volume of this entire solid here. So once again, if you have a composite solid, you have to break it down into pieces you know how to work with, and then add them all together at the end. The next one here is just kind of your basic sphere problem. So it says the diameter of a sphere is, let me get my glasses back on here. The diameter of a sphere is 13 millimeters. Calculate the volume, and it says use 3.14 for pi, round it to the nearest tenth. Do not round any intermediate computations. Basically what this means here is if you're doing a problem, don't round it until the very end. That's what intermediate computations mean. Intermediate computations are the little work you do in getting your answers. Like here, these would be intermediate computations because they're not my answer. They're just answers I get to get my final answer. They're kind of my work that I'm showing. So basically this is saying don't round until the very end. So luckily we actually really don't need to. So our volume of a sphere, if you don't remember, is 4/3 pi r cubed. So in this case here it'd be 4/3 pi. And then if the diameter is 13, we have to cut 13 in half. And we get 6.5. And that's going to be my r cubed number. So 6.5, because again, I want the radius, not the diameter. So then I go ahead and do my calculate work here. So 4/3 times, now it wants us to use 3.14 for pi. That's what directions say. Use the value 3.14. So 3.14 times 6.5 to the third. Again, to the third is this little caret key, and then 3 there, which gives you to the third. And again, make sure you do read the directions, because if you put a pi in here, that means your final rounded answer is going to be slightly off, and Alex is going to tell you you're wrong, and then you have to go back and redo the whole thing. So make sure you read the directions to know whether you use pi or 3.14, because they are picky about that. Round to the nearest tenth means 1 decimal spot, so 1149 point, at 6 rounds to 7 up to an 8, so 1149.8. So 1149.8. This would be millimeters cubed. So millimeters cubed. And again, if they had you do something like if they was going to fill this space with chocolate, and chocolate cost 5 cents per millimeter cubed, how much would it cost to fill the sphere? You'd simply take your spherical answer, your volume answer, and multiply it by what the cost is. So again, if they do tack on extra little problems here, if they do tack on extra little work, it's usually not that hard to take that extra step. So this one's a cone. Again, basic problem here. Use 3.14. Do not round anything. So do not do any rounding, and be sure to include correct units. So we have a cone here. The radius is 6 and the height is 9. Again, this is the height we want for volume. This height right here, that's called the slant height, often abbreviated as a cursive L. That's used for surface area in some cases. but we want the volume. So we're concerned about the direct or the perpendicular height and the radius, not the slant height. So the volume for a cone is area of the base times the height divided by 3, same as a pyramid. It's just that since the cone is a circular base, we know that this capital B here is just pi r squared, because that's the area of the base. It's the circle. So times h over 3. Let me make my marker a little bit thinner here so it's a little bit easier to write. So pi times, my radius is 6 yards because that's going from center to edge. So I don't need to cut in half. So pi times 6 squared times my height, which is 9, all over 3. So if we do some arithmetic here, we do, now it says use 3.14 for pi. So we're going to use 3.14 times 6 squared, which is 36, times 9, and then divide that by 3. And we get 339.12. So 339.12, and this would be in yards squared. Not yards squared, sorry, yards cubed, because it's volume. So it'd be cubic yards. Almost made a mistake there. But as we know, I'm not always right, but I'm never wrong. So um, that would be how much volume it takes to fill up this cone here. Again, simple formula, just as it is for a pyramid, just the circle's a base, so B is just pi r squared. For a pyramid here, find the volume of this rectangular pyramid. Now, for a surface area problem, rectangular pyramids are kind of tricky because in a surface area problem, you have to figure out how much area is in each triangle, and that means that if it's a rectangular prism, this triangle over here is going to be a little different than this triangle in front. But for volume, it's just the same basic formula. Volume is equal to area of the base times the height divided by 3. And since it's a rectangular prism, I know that the area of the base is just length times width. That's the area of the base shape. And then times height divided by 3. If it was a triangular pyramid, this would be base times height divided by 2 times height divided by 3, because that's how you get the area of the base for a triangle. So again, just make sure you read the question and figure out what type of base shape you're dealing with. So in this case, my base shape is an 8 by 5 rectangle, so it'd be 8 times 5. The height of the rectangle is 6, all over 3. So 8 times 5 is 40, 40 times 6, and then divide by 3, and we get 80. So it'd be 80 feet cubed, because again, it is a volume. And that would be the volume of the pyramid. Again, if it was a triangular pyramid, like a triangle on bottom, I would do the area of that bottom triangle and then times it by the height of 6 in this case. So always focus on your base shape first. Basically ignore the rest of the pyramid, just focus on your base shape. Think of it as a 2D object, get the area of that base shape, and then times it by the height, and then divide it by 3, of course, if it's a pyramid. Speaking of triangulars, this is a triangular prism. Now, for a prism, it's almost the same thing as a pyramid, except you don't divide by 3, right? Prisms are not divided by 3. It's just area of the base shape times the height. Well, my base shape here is a triangle because it's a triangular pyramid. So this triangle would be one of my bases. The other one would be the one in back, but this one's labeled, so I'm going to use that one. So my area of the base is little b for the area of the base triangle times h, which means the height of the triangle, not the height of the prism like this h does, and then divided by 2. So that's how I get capital B. I'm going to times this by the height of the prism over over nothing, actually, because it's not a pyramid. I almost divided by 3 there when I shouldn't have. But again, not always right, but never wrong. And I would call this h sub 1 for the height of the prism, not the height of the triangle. Now, triangle pyramids can be a bit tricky because you're looking for multiple heights, the height of the triangle and the height of the prism. So the way you know which one's the height of the prism, the way you know which h this one is this h is the one that connects the bases. So this one right here, I'm not even going to try to type it out or write it out here. I'm just going to type it out. So this h right there is the one that connects the bases. So this is my first base. The other one here is my second base. And the line that connects them, this line right here, this 10, that's the height of my prism. So that's going to be on the outside here. That's this h right there. The height of the triangle is simply how tall the triangle is, which if we look at this front triangle, it looks to be 7 yards tall. So this would be 7 times the base of the triangle, which is 9. So times 9 all over 2. Again, I should say connects the bases of the prism. So this is the base of the triangle. This is the height of the prism because it connects the two triangular bases in the shape. So in this case here, we will get a decimal answer. Actually, we might not. So 9 times 7 divided by 2, and then times 10. No, we don't. We end up getting 315. Nice whole number. 315 yards cubed. And that's the area of a triangular prism. So again, focus on the base triangle first. Get the area of that. That's what this spot here is. 9 times 7 divided by 2 is just finding the area of this triangle. And then times it by however long or high your prism is. So figure out what the line that connects the two bases, how long that line is, or those lines are, and just multiply the area of your base times that. And yep, that wraps it up there. So those are going over the volume formulas of each shape for a prism, a pyramid, a cone, a cylinder, and a sphere. Actually, I don't think I did a cylinder one here, did I? Did I skip one? No, let me just do a quick cylinder one just for completeness sake, because it's very similar to a cone. So let me draw a cylinder real quick. You'll get some art tips here. Ha ha ha. So um, clone that. Look at my perfect circles. I'm so good at drawing them. We get a line here. Nice straight lines because I'm that artistic. And let's say I give you that the height of this cylinder is 12 meters, and I say that the diameter is 6 meters. And I say find the volume. Well, the volume of a cylinder is area of the base times the height. And because it's a cylinder, that means the base shape is just pi r squared, and then we times it by h. So if the base shape is a circle, area is pi r squared, and then times it by the height of the cylinder. So in this case, what I would do is I would do pi times the radius of my cylinder is not 6, because again, 6 goes all the way across. The radius of my cylinder in this case would be 3, which is half of 6. So 3 squared. And then the height of the cylinder, again, the height of a prism or a cylinder is the line that connects the two bases, which in this case would be 12. So times 12. And if I said write this in exact terms of pi, I would simply do all the non-pi stuff. So 3 squared, which is 9, times 12, and I would get 108. So it'd be 108 pi meters cubed. Or if they want it as a decimal answer, you would do that times pi, and you get 339.29. So 339.29 meters cubed. So that's how you would do the volume of a cylinder. Again, very similar to a cone, except you don't divide by 3. Just like in a prism, you don't divide by 3 on a prism, you do it on a pyramid, but not on a prism. So again, just a quick review of all the basic shapes there. Again, if they throw a word problem at you, just do the volume like you normally do, and then figure out whether you're going to divide or multiply or add or subtract to get that extra little bit because it's a word problem. And remember that volume is about the space inside of an object and filling it up, whereas surface area is about painting or covering a space. So make sure you pay attention to that question when it comes up. That's it for this video. Hope you enjoyed it. Please take your RPS on Alex. Make sure you upload your work to Google Classroom so I can actually check it and give you some partial credit. And again, if you have any questions, comments, concerns, please let me know. And I will see you, metaphorically speaking, next week.